So hello and a warm welcome to the last video in this little series where I describe the design changes of the AR4 3D printed metric robot arm to the base design from Arnin Robotics. And now we get to the joint 6. And the joint 6, as previously described, isn't one part, but actually three parts, even though I wanted to combine it all into one part. Let's hide the end effector adapter. No, there we go. And now we have only the J6 housing. So the housing is split into three places, on the green side we have the J5 pulley. The yellow is the stud that registers on the tapered roller bearing. And the tapered roller bearing is preloaded via a M5 machine screw that screws into here and registers on the bearing cup, J6 bearing cup. I also have heat-set inserts in the J6 for M4 grab screws, so you could also preload it via those 6 grab screws. But in my case I didn't need to do that, but it is in place. The J6 motor is held in place via 4 M3 machine screws on the front of it. In the base design this was a little bit different, because in the base design it was held in place via 3 M3 machine screws, grab screws on the back side here. But of course the 3D printed part isn't strong enough to hold this, so I redesigned the design. And I split the whole assembly into 3 because of the orientation in which it is printed. So of course we couldn't print we can print accurately the green pulley and the cutout for the motor, which is also round, and we would have a huge overhang if we were to print it on basically if this was attached to the base plate of my printer and this were where the Z-axis, it would be very messy. So I split it into 3 parts. I designed some location studs on both ends. So there are also location studs. You print those 3 parts and glue it in place with epoxy glue. And also I drilled a hole for a M3 machine screw, which is very long, because this 8mm stud registers for the 608 roller bearing that takes the force from the belt tensioning mechanism from J5, and this cylindrical stud in my first design couldn't take the shear forces, so it sheared right off at this surface. So I just reinforced it with a machine screw and now it doesn't break. And the whole assembly is held in place via the front bearing cup from J5. the end effector, at the moment, the end effector adapter is just this design, and I'm planning to design different end effectors which could locate onto this whole pattern for easy assembly and disassembly. So to recollect, this is my little 3D representation of the actual robot I built, and it can move in 6 dimensions, of course, into J1, into 1, 2, where 3? Oh yeah. Nope. Oh, whatever. 3, 4, 5, and 6. So, thank you for the attention. I'm still new to this video thingy, so I'm glad that you bared with me. Thank you for watching.